Okay, we're back on the record. Purpose of this one is to drag and drop the labels to the hydrocarbons we've got here. And to do this, you need to understand the nomenclature of hydrocarbons. Once you get to about 5, it becomes quite easy because it starts out with things like pentane, then hexane, then heptane. A bit lower than that, it's slightly more complicated. Carbon 1 is methane, carbon 2 ethane, carbon 3 propane, carbon 4 butane. So we'll have a look at these examples. So we start off with heptane. So hept is 7. Drop that in there. Methane, as I mentioned, is the simplest one, and that's carbon 1. Octane, again, pretty straightforward, 8 carbon atoms. Butane, that's 4 carbon atoms. Pentane's an easy one, that's 5 carbon atoms. Decanes, slightly more difficult, that's deca always means 10. Propane has 3 carbon atoms, and ethane has 2 carbon atoms. Nonane has 9 carbon atoms, and hexane, an easy one to finish with, has 6 carbon atoms. So now we click check answers to see if I've got everything right, and I have got everything right. Okay. Right, this is talking about carbon chains we've got more than 10 carbon atoms in. Now what happens here basically is you count the first 10 and you call them decane. Then you start counting the next few. Quite important in biological chemistry. So we're starting off here with C12. So knocking off the 10 for decane, that's 2 carbon atoms. And do is that one. Under decane, una is 1. So decane plus 1. C13, so that's decane plus 3, so that's tridecane. And finally C14, so that's decane plus 4. Again, we'll check to see if I've embarrassed myself. No, hold on. Carbon-carbon bond angles. As we discussed on a number of occasions, 109 degrees 28 minutes is the natural carbon-carbon bond angle for sp3 hybridization. We're talking about a later lecture, so we can take that and we can drop it under that one. It agrees with it. Find away the least strained of these energy configurations here. If you take 90 degrees, that's going to be a square, so we'll drop it into the ring that has 4 corners. Takes a lot to make. I did mention one, the cyclobutene pyrimidine dimer in electron biochemical reactions. It's involved in damage to DNA, if you recall, which leaves the final one 60 degrees in the triangular one. Pretty strained, very unlikely you're going to see them in biological chemistry. I can't think I've ever seen one. Okay, so in this case what we're doing is taking the prefixes. We saw early on the simple alkanes and their names. We can derive from them prefixes which we can use to describe bigger molecules. So for example, in this case we've got CH3R. The R group is the rest of the molecule, and it's this bit here we're trying to identify, the CH3 bit. But we're starting off with butyl. Now if you remember, but was 4, so this is a little bit more complicated. What we're going to do is look for the number of carbon atoms. So we're looking for 4 here, so that's 1, 2, 3, 4. We'll drop that into there. Methyl's the easiest one, that's just 1 carbon atom. Hexyl is 6, and I suspect that these are in order. 1, 2, 3, 4, 5, 6. So hexyl's there. Heptyl then will be 7. I'm going to be embarrassed if this doesn't work, aren't I? Pentyl then will be 5. Propyl will be 3. And ethyl will be 2. So again, these are based on the parent hydrocarbons, the parent alkanes. And I'm correct, yeah. So we identified the longest chain of carbon atoms and we gave it a suitable prefix. Right, okay. We're doing a little bit of organic nomenclature here. We're going to have a look at some molecules and you're going to name them. There's some rules there. We found the longest carbon chain, and we find any side chains or functional groups, and we specify where they're located. So we'll kick off with molecule 1. There's molecule number 1. So pause the video now if you want and have a little play yourself to figure out what the longest carbon chain is and what any side chains or functional groups are. Right, okay, I'm going to look at this now. There's 1, 2, 3, 4, 5 appears to be the longest carbon chain. So that would make it pentane. Now this is a methyl subgroup attached to it. So that's going to be methyl pentane. And if we start counting from either end of this long carbon chain, we go 1, 2, 3, or 1, 2, 3. It's always going to be 3. So the name therefore is going to be 3-methyl pentane. You're not sure, draw the molecule out. Make sure you can identify the longest carbon chain, identify the side chain, which is a methyl group here, and then put the position for it. Okay, so molecule number 2. Okay, so what have we got here? What we've got here is a slightly misdrawn molecule, because that should be CH3. So that bit's been drawn wrong by someone, and it's clearly me. Right, so we identify the longest chain here. So let's have a look. 1, 2, 3, 4, 5, 6. Or alternately, 1, 2, 3, 4, 5, 6. Now, this is slightly more complicated, isn't it? It's definitely hexane, isn't it? But then it's got 2 functional groups in it, in effect. So what we do is go 1, 2, 3, 4, 5, 6, because that and that are identical. So it's going to be a hexane, which has a methyl functional group and an ethyl functional group, which both happen to be attached to the same carbon atom. Now it's a rule that when you identifying the position of functional groups, you always take the lowest number for the carbon atom. So if we start here, we go 1, 2, 3. So these are both attached to the 3 carbon atom. We could have gone 1, 2, 3, 4, but that would break that rule. So taking all that together, we can bring up its name, which is 3-ethyl 3-methyl hexane. I believe yes, 3-ethyl 3-methyl hexane. Okay, moving on to molecule number 3. This is a pretty simple one. It's a long chain of carbon atoms with a OH functional group on the end. Let's have a little think about that one. Okay, now the sort of thing we could do here is what this is OH. Is it in the 1 position? Is it attached to the 1 carbon atom? 2, 3, 4, or the 4 carbon atom? Again, we always go for the lowest one, so its name turns out to be 1-butanol. It's an alcohol with 1, 2, 3, 4 in the chain, therefore it's a bute, and we always call it the lowest one, so 1-butanol. Okay, now this is a chemistry lazy one. I haven't drawn all the bits in, so you've got to sort of figure out where the carbon atoms are yourself, and then think about how you're going to name the position of these 2 OH groups in it. Let's have a little think, and then we're going to move on in a moment. Okay, so there's a carbon atom there, and there's a carbon atom there. So the base molecule is ethane, and it's got a couple of OHs. Now, we didn't necessarily cover this, so I'm going to move straight on to the name. It's ethane 1,2-diol, or as it says, or 1,2-ethane-diol. Let's have a look at it again. So 1 carbon atom, 2 carbon atom. These are identical, and there's one on the 1 position and 1 on the 2 position. Organic nitrogen is important, and there's some useful links there which are in the notes. And also available by this interactive resource. Okay, aromatics. This isn't particularly a questiony one, it's more one just taking us through some of the concepts. Structure benzene we discussed a few times. Kekule famously fell asleep in front of his fire and was able to eventually figure out that carbon atoms in benzene, all 6 of them exist as a ring. Now I've suggested a number of things here, some which I'm going to modify slightly. Okay, so anyway, have a draw, pause the video, and draw out benzene with all the atoms shown first, and then in the skeleton form. Okay, I'm going to move on. So there it is with 6 carbon atoms in a ring, each of which has a hydrogen attached to them, and apparently a series of alternating double and single bonds. The shorthand version is that one there. As we discussed, it's not quite correct, and we know it's not quite correct for a number of reasons. One I've mentioned here, which is a sort of chemically one, and to be honest, I'm not sure why I use this one. A better one is, if you look back at this, we discussed in a later lecture the fact that double bonds and single bonds are different lengths. A single bond is slightly longer than a double bond, which again is slightly longer than a triple bond. So if you have alternating double and single bonds, you'd expect these bonds to be longer than these bonds, and the single bonds to be longer than the double bonds. It turns out all the bond angles are the same length. There's a little bit of chemistry there which I've explained, and we talk about addition reactions there briefly. What you should be able to see there is a double bond. It's not showing up on the screen here, but there is a double bond there. What happens is we're said to be adding bromine across it. But I'm going to skip over that because I'm not entirely sure why I included that. I mentioned the fact that the double bonds and the single bonds aren't alternating, and we know they aren't because they're the same length. Another issue is that it's flat. I will get to you all at some stage later in the year, and we'll have a tutorial using the molecular models where we'll make models of both cyclohexane, the alkane counterpart of this, and also benzene. You'll see that cyclohexane is a model which is not flat, it's three-dimensional, whereas benzene is in fact flat. So there's something happening here, and something that's different is delocalization of electrons. So electrons in the double bond are in fact delocalized effectively into rings of electrons above and below the plane of the ring, which looks like this. There's a good link there, which will take you to information on the website. I'm fairly sure it's the the Chem Guide link, I think, which I've suggested to you on a number of occasions is very useful. Okay, that's my commentary on the first of these tutorials. I'll probably do a few others because I can do these fairly quickly. But of course, what you should be doing is them yourself. The tutorials, my colleague has guided you through them in the sessions during the year, and I'm doing this to give a little bit of a commentary, as I say, but ultimately it's up to you to do the work yourself. And I assure you that if you work hard and you can follow all the material in the tutorials, you will be very successful in the exam. Okay, so I'll be back later on with a review of tutorial 2.